Hello guys, welcome to the 8th session of SillyHacks. Allow me to introduce SillyHacks to you. Now SillyHacks is a 48-hour long hackathon where you do not have to solve any particular problem, but you just want to have fun, right? So if you want to register to SillyHacks, you can register down below. Now SillyHacks has been designed to bring back all the fun there is during a hackathon. You do not really have to solve a particular problem, any serious problem, but it is just designed so that you can have fun. You can connect with people during the hackathon. Now, talking about today's speaker, he is a long-time open source contributor. Now, he started with Google coding, participated for 3 years straight, and finally, he became a Google coding finalist. He is a project maintainer at Force Asia and also at Circuitworks. He is also a docs mentor at Circuitworks. He recently won MLH Orientation Hackathon at MLH Fellowship 2020. His recent engagements are that he mentored in MedHacks 2020 by John Hopkins School of Medicine, and he also gave a talk there. Now, let's welcome him. So, hello.
Hello, everyone.
So, let's get started with the session, and I'll just let you know that if your screen is visible or not, and the light drop off so that you can get started with the session.
Okay, sure. Thanks a lot. So, I'll be sharing my screen now.
Sure.
Just let me know if it's visible.
Sure.
Yeah. And
Yeah, you are visible. I would suggest you can open the presentation mode if you want.
yeah.
Great.
So, welcome everyone. Today's topic is we're deciding to dump the bulky packages. As we all know that the size of node modules folder just exceeds the sky limit. And sometimes we also figure out, like, do we actually need so much code to do a very small thing? For instance, if you want to write a very simple server, do we even need to include all the 43 packages that Express comes with? So we'll be discussing all those parts, and then at the end we'll be writing our own framework, which does the same thing in essentially about 4 to 5 files. Yeah. My name is Yash Verma, and these are the social handles. You can send in a message anytime, and maybe we can have a discussion about anything you're interested, or if you want to, discuss any topic or any project, I can surely help you out with that. Now, moving on straight away to the topic that we have, what do we do today? We're building a web framework from scratch, and the legit question that many of you might have right now is, when there are already so many libraries that already do what we are doing, why do we exactly want to write the framework again? The answer to that is this particular quotation, which says that what I cannot create, I do not understand. And this is the basic fundamental reason why you should go about writing the things that you use. You will get to explore each and every tiny bits and pieces of that framework or that library, and you also get to know a lot about the language experience. Now, moving on, this is like personal experience that I've had about writing, about the advantages of writing like things from scratch and the practical use of it. As we know that there will be no practical case if we compare the framework that we write and any industry proven framework like Express, but it shows off the difference between you and other people. For instance, if you take the number of React developers in the world right now, it would be in millions. But if you take the number of people who've actually written React or who've actually written any state management machine, then you would condense them down to a few thousand or a few hundred. So that is what basically separates you from the crowd, and that's what happened in the fellowship interview. My fellowship interview was not mainly about the project I submitted, but it diverted onto the internal functioning of Express, maybe because they saw that I wrote a framework. So they went about asking me the details how Express was working under the hood. So always when you're doing things that people do not do, you would get an advantage somewhere or the other. Now, moving on, if you have the question like this is a like very small time framework workshop, and what exactly can a framework do? So we are not going to write a framework that can do everything. we are just limiting our scope down to these few features. That is, we can handle the HTTP requests. It means we can handle the various requests that come in, get, post, put, delete, etc. And then the headers that are there, for instance, if you want to send a custom header for authorization, or if you want to, identify your request by adding a timestamp or by adding a signature, you can do that. The URL routing. Now, many people use frameworks only because they want to route the URLs. So this is one of the main feature, or when this is one of the core component of our framework. The next is data parsing from URL. Data parsing from URL basically means that when you open a link like get slash book slash one, so your framework must be able to easily parse the data from the URL. It means you must get that the user is trying to access a book which has the ID one. So it must provide a nice consumable API that the end user or the developer that's using your framework can use. And the last is obviously if your framework cannot send responses, it is basically useless. So yes, we'll be writing a response module as well, which supports some custom response codes. Now the question again arises, will we replace Express? The answer to that is yes and no. And the reason for that is if you want at the end, if you can mold this framework into something very specific that you want to do, you can surely use it. But for production purposes, obviously not. So it's basically a design choice or maybe a code choice, just like people have between Android or iOS, or maybe React Native and Flutter. It's just like that. If you want to choose one way or the other, it's completely your choice. If you can move ahead with either of the tracks, it's if you can carry it forward, it's completely your decision to make. Now, what tech are we using to write this framework? Now, since we have already discussed about node modules and JavaScript, so you could have guessed that we'd be using TypeScript and any code editor that you like. Now, I'll be using VS Code. That's my favorite one. You're free to use any one that you like. What are the prerequisites of this workshop? Now, like necessarily there is none, but still just for the sake of mentioning, I'll say just basic JavaScript syntax. So if you're clear with how the basic JavaScript syntax is, how to declare functions, classes, or how to call functions in classes, write comments and all, then you're good to go. Now, I think I've gone at stretch talking about the framework. So now let's get into the code and get things started. What I'll be doing is I have already written the framework and divided it into small consumable checkpoints so that it's easy for you to refer it in the future. So I'll be sharing a GitHub repository with you and in the comment section. So the repository would be with you anytime. And yes, to get started, you would need to clone the repository. So what we would do is we would write git clone and then copy the repository link and then paste it. Now once you run it, you will get the entire code of the framework. Now I've already done that to save time. And just in case if you are new to JavaScript, you will need to run one more command, that is npm install, which would basically install all the dependencies that the framework has. Now keep in mind that if you look at across all the files that are there in the master branch, you will see that these are mainly configuration files and no actual code exists as of now. And if you check out the package.json file and you scroll down, you would see that the mainly dependencies that we are using are development dependencies, which means that they will not be shipped to the end user once we have built our product. The final dependencies that the user would require to install are just these three. One is for loading the environment variables, that's also optional, and then TypeScript and TS to run the files. So we are just creating things from scratch. And all these repositories are basically TypeScript definitions or linter configurations, nodemon to hot reload your server, just in case if you save a file and then you do not want to run the server again, you can use it. So this was the first part. If you want to browse to the code, you can always do git branch, and then you will see the list of different checkpoints that we have. Let's get started with the first checkpoint. So to move to that, you write git checkout checkpoint -1. Okay. Take the README. In the read, we on onto every checkpoint we have given in the form of points what all are we going to do in this particular checkpoint. So in this particular checkpoint, we'll be only setting up the project structure so that we can write code into it, and then we'll be explaining the code structure while we have done that. So if you see to the left side, we have this new folder created. That's the SRC folder, and within it, you will see a bunch of different files. Now, these are all the files that would be essentially required to create a framework. Now, the server.ts file will contain just the code for calling our instance. The app.ts file will contain the functions that we write. For example, in Express, like you do app.get, app.post, and then attach the middlewares there. So all those things will be there in app.ts. If you check out this point, we have divided the framework into multiple different parts so that it's easy to maintain and extend. So that all the things related to the request are here, request.interfaces.ts. That's basically the type definitions. The responses module would reside here. The type definitions would reside in responses.interfaces.ts. Similarly for router.interfaces, and then the Shatabdi.interfaces. Now, just in case if you're not a resident of India, it is to inform you that Shatabdi is a fast express train that runs across India. So just on the lines of express, we have named it Shatabdi Express. Now this was all from the first checkpoint, and now we are free to move on to the second checkpoint. And if you have any questions, feel free to ask them in the live chat. I'll be taking them in once we move further. Now we move on to the second part, that is git checkout checkpoint 2. And if you check the README, it says that we are going to set up interfaces for all the entities. We're going to set up the interfaces for all the entities. So if you check out these files, these are request.interfaces.ts. And yeah, once you open it, you will see that we are importing import HTTP from HTTP. It is a built-in library of JavaScript. So we are importing that. Export is to make this interface accessible or importable into different files. So that we're using this export because we want different files to have access to this particular interface. We name it request, and it extends the HTTP library's incoming message method. If you're not very familiar with the concept of object-oriented programming, what we're doing right here, this is called inheritance. We basically take this library or these definitions, and then we extend them and we give them a name, that's request, and then we add whatever things we want to add additional into it. For instance, we are adding two things. First is params, and the second is body. Now, if you're curious, this params would contain the data that comes into the framework. I'll show you. It be visible. So if you check out this, and if you've ever used Express, you would know that these things are used to capture the data from the URL. So this is essentially a wildcard which captures every request that is there. Like for instance, if you do look at parents, and if you do apple, mango, banana, and then you put an and at the last, you'll get an object which says apple. One is apple, second is mango, and the third is banana. So that is all stored in the params, the body that the request would have. Now the next is responses. The responses module also inherits a lot of the definitions from the HTTP library. And then we have three functions that are defined here. Now these three functions, you can identify they are functions because you have this identifier and then you have the parenthesis here. And between them, you can see the different parameters that it would have. Now, this number means that this particular parameter would contain a number, and that is essentially just the difference between JavaScript and TypeScript. If you were to write this in JavaScript, you would just omit the number, any, and string type, and also the responses. So, yep, you find one function that's status, the second function as JSON, and the third as send. Another importance of using TypeScript to define interfaces is that whenever a user is using your end product, they would get an excellent support in the code editor. So as soon as they would do something like app dot and sorry, they would do app and then do dot, and they would get a list of all these functions. And if you check this particular file, which will be running in the last checkpoint, you see if I say status, you see that's how we are using rest.status 401.json. Now, if you look close enough, you see that the status method also returns an instance of response. And if you see clearly, this response is same as this one. So what this does is it allows us a particular functionality of JavaScript, that's method chaining. It means that you can call different methods of the same function of the same class, and it allows you to do something like res.status.401, and then again you are able to call the function on top of another function. That is the advantage of returning of returning the object itself. This was all on the interfaces part of the response interfaces part. In the final interface that we write are the routers. First of all, as I told like already, the reason for using the export was we could import the same into different files. So we see the responses interfaces being included here, the request interfaces being included here. Now we define all the different methods that our application should be able to accept. These are get, post, put, delete. Essentially, this just makes sure that the user does not provide any arbitrary string and that the choice is just limited to these four. Now, this is the layer. Now, the way we have designed this framework is we have decided that, okay, the user registers a route, and when they have registered a route, the request will pass through different layers. Now, this is one layer. Every layer gets a request object. It means that the request that's incoming, it goes through every layer. So we pass the request. The responses, like every request that comes inside a layer, will also leave. So that is basically the responses module. And because we are chaining them, so every next layer requires the response from the previous layer, so that they can easily share the data. And the continue request is a boolean that's optional. And if you have used Express, you will see that there is a function known as next. So it ensures that the request moves to the next layer. And the last is the route map. Route map is the data structure in the form of which we are storing all the things that are there, all the routes that are registered in the framework. For instance, whenever a user does something like app.get, they specify a string. In this case, this is a response. I'll use a different example. You might confuse the response. Yes, what they do is they first of all specify a string that goes like with the name /home. So you see every route map has an ID, has a method, has a pattern, and a layer. Now these things are assigned by the framework itself. This method is picked up from here, one of the four methods that our framework accepts. The ID is just a normal number, which is used to uniquely mark each and every route that is registered, and a pattern, which is an array of strings, which is extracted from this. Now that was all on this checkpoint. We have already defined three interfaces, that is the request.interfaces, responses.interfaces, and router.interfaces. That is all for this checkpoint. Now we move on to the next checkpoint. In this one, we would be writing the router. Now, as I've already told, router is almost the core of the framework that we are writing. So I'll zoom in. As you can see here, the first thing that we do is we import the different interfaces that we have declared till now. This is all magic of the export keyword that we have used. So we can now use them here. It shows the reusability of code, as we say. So first of all, we are defining a class. The main reason for defining a class is so that we can store the data as well as the methods into one place. and we do not have to go about like calling different functions randomly. So everything resides in one place, and the code does not clutter around. Now we define the route maps interface, and what we do here is we define that okay, we are going to have a data member that is the route maps, and it would be an array. When I say it would be an array, it means that there are two ways to tell TypeScript that it is an array. You can either use this notation, which tells the data type, and then you put square brackets, or you can also do ARRAY, and then you put the data type here. Now this also does the same thing. So we define an empty array. On the constructor, we say that first of all, we are going to have no routes by default. And then we move on to the register function. The register function the is the way whenever a user does something like app.get, internally the framework would call the register function. And if they do app.get, the method, as you can see, the method would be get pattern of string which the framework takes from here, that in this case would be slash multiple. And then if you see the triple dots args, and the data type for that is it is an array of layers. So this ensures that this particular function can take any number of arguments. Now if you check out this particular function has 1, 2, 3, and 4 arguments. This particular function has only 2 arguments. This particular function has 2, and this has none arguments. So basically, this feature of ES6 specification it allows a function to accept any number of arguments, and that is what we use in attaching any number of layers onto any request that is registered. So what we do is all the layers that are passed, we do a simple for loop. Now this much is the for loop, and then we do this dot route maps dot push. So initially we had declared an empty array right here. So what we do here is this dot route maps dot push. We are pushing a new item into it, and that contains all this information. Now what all information is this? First of all, we save the timestamp of the ID. This is completely optional. This has no use in the data in the framework as of now. You can like easily skip it. There would be no problems whatsoever. The second is the method. In the method, we are saving which type of method we must listen to. Again, but that would be one of the 4 methods that we accept. The pattern, the pattern whichever we get, we are exploding it or we are splitting it in terms of slashes. And you will see a very interesting use of this just in the next part. And then the layers, all the layers that are there, we save them into the array. So now all the routes that are registered, they are stored in this particular data member. Moving on, this particular function is the biggest function of the framework. And what this does is, I'll be explaining that line by line. So first of all, what we do is we say if we do not have a URL or the URL is empty, just assign a normal slash at the starting. Now, this helps us capture this case. If you want to listen to the route, that is, if you want to just have access to the route, have access. For instance, if a user does localhost :3000. So you would be like, what? There's nothing like this. So you're just accessing an empty slash. So this is what is done in this case. So because the people would usually access a site like this and not like this. So just in case you have things empty, the framework would automatically add a trailing slash. The next thing that we do is we are replacing any number of slashes that are there after the first one by one. For instance, you do not want the framework to break when you enter something like this. What the framework would do is it would just replace all these slashes with a single slash. Next, what we do is this request URL.split is whenever a request is made into the framework, we simply just explode it or split it in the form of an array. So if the user opens something like localhost :3000 /apple/mango/banana. So what we get from this is we get an array of 3 items which has these 3 items. Now this is what we get. Now here we go about matching the entire framework, matching the entire URL route into the routes that are registered with that. So first of all, we check if the route dot method is equal to the request dot method. So if you do not want our framework to sending responses, if for instance, if you register a route for only a get method and a user sends a post request to that particular route, so you do not want the framework to confuse in that part. So the first thing that we do is we check if the methods match. If the methods do not match, you simply return the control. On the second part is if we say route dot pattern dot length is equal to exploded URL dot length. Now this is where the advantages of splitting the URL on terms of the slashes come in, because even if we are when we are dealing with wildcards in frameworks, if the user opens something like apple slash mango, and on the wildcard we have registered it as apple slash chicken. Now we want the framework to compare these two things, but at the same time, to optimize the code, we do not want the framework listening for something like this. Now, if you see, these two should match and these two should not match. So the way which the method with which we are doing is we convert these into arrays. So we convert these into arrays, and then what we do is we simply check the length. So the length of this one would be 2, the length of this one would also be 2, and the length of this one would be 3. So when we are comparing the lengths, if the lengths compare, only then we move on further, and if they do not, we simply reject. So this is the way we are able to make the wildcard functionality possible. We explore it, we split it in terms of arrays, and then check the length. Okay. So now we are accessing each and every fragment of the URL. For instance, when we say route.pattern.len, like a simple for loop, what we do is if any pattern of I, which means first of all we'll open this, process this, then we process this, and then we process further. If it includes a simple colon, which means that you are trying to use a wildcard, so this particular route registration would trigger this if condition if it includes a simple colon. Then we add this parameter to the params object. This params object can have anything because there can be any number of arguments. So what we do here is we save the data that is there into the params data member. And just in case if the patterns do not match, then we simply say error equals to true, and then we pass the control. Now, this particular case is triggered when we do something like this. Yeah. Both these two have the same length. This one would get triggered. We would save the data in here. But when we go about checking this one, this would the control would never reach here. What we do is we simply check this one. If the route pattern Apple and Lenovo, the length is same, the execution comes in here. And if we check the route pattern I is equal to the exploded URL's ith location, and we see this one would return a string as Apple, this one would string a return as Lenovo, we say, okay, these are not matching, the condition checking is failed. Now, if after all the processing that was happening over there, if there are no errors, then we simply say that assign the parameters and then call the layer by passing in the request and the response objects. This was the biggest function that we have. Just a second. This was the biggest function that we had in the just a second. Sorry. This was the yeah. I would request the organizers to just I'll be back in a bit. Just a second.
Sure, no worries. So guys, we might have some technical difficulties, so we'll be back in just a split.
Sorry for the disturbance. So now if you see here, you see that if there was no error, we simply call the layers that come. And just in case the incoming request has not matched with any of the URL that we have already stored, we send a 404 response and we tell that, okay, it is the request was not found, and we display whatever was not found. Now this was all in this particular point. Now we can easily move on to the next checkpoint that we have, that is get checkout checkpoint dash 4. Now we'll be writing the module which is supposed to send the responses to the users. If you check out the responses.ts file, you see now, don't worry if you're a bit too overwhelmed with the last checkpoint. That was necessarily the entire code that we had. And all these modules are just now, we are finishing off the framework now. This particular class is called the responses class, and it is extending the http.server method. What this would do is, this would basically inherit all the functions that JavaScript natively provides for the responses. And we have assigned a constructor here. The super keyword is used to launch the constructor of this particular method, this particular class. And what we do is, whatever the response object that we get from the previous layer, as I've explained already to you, since we are using a layered method, whatever responses that we get from a previous method, we need to pass it on to the next method as well, because we want the final response to contain all of these things. And then we are doing an interesting thing here. We said that this .response.set header x powered by SillyHacks 2020. Now this means that if you have ever went a bit deep into how Express sends its responses, you would see that every response that Express.js sends, there is a small header that they attach. That is basically the signature of the framework. You can disable it, but by default that's enabled. So we are also doing the same thing. We are assigning a branding of SillyHacks to every request that is being sent from our framework. Now, the next method that we have is the status method. It accepts the first parameter as an input code. And by default, we have assigned it to 100, which is OK. And it also returns a response object. Now, as already explained, the main advantage of using this response is the main advantage of returning a response object is that we can use method chaining, and we can use res.status dot and then another function that we have here. Now these are just different functions. If you have used Express, you'll definitely know this. There's a very easy to use function that says res.json, and you provide any JSON object and it will display the content onto the browser. So we also implement a similar functionality. Whenever our user sends in any JSON object, it does not return anything. So you would see the people using res.json. Yeah, res.json. It does not return anything, and that is the reason there is nothing on the left side of this function. And it sets the content type to application/JSON, so that the APIs that are consuming your framework or that are interacting with, whenever you're writing an API and you're writing in this particular framework, so you can always, whenever you're sending a JSON response, you can tell the content type in the header as well, so that they can easily parse it. And we just convert the JSON object into a string. Now this would throw in an error if you have circular JSON structures, but that's just the default problems that we face while converting it to strings. So that's not essentially a bottleneck. So we just write the responses and then we end the response. Similarly, if you want to send a normal string onto the user, what you do is you just set the content type to /plain, and then you write the responses. The set header is a custom method, which you will see here. Yes. Now, if in this example, if you see, we say res.setHeader, we first select the like we are using it of this form. So every header that we are sending, it's something like a token and then a colon, and then we have a value. So that is what we are doing in this part. So this dot responses dot set header, the name is the token, and the value is the value. Now this was all on the responses part, and you've congratulations if you followed till now. You have successfully written the responses module, and out of the six checkpoints that we have already covered four. Now moving on to the final, almost final checkpoint. Going to hit checkout. In this one, okay, okay, we are on the checkpoint 5, and in this one, we'll be writing this. In this one, we are bootstrapping everything into one callable entity because when you're using Express, you do not really care how the internal functionings are implemented. All you need is you need a simple function that you call and then that you can use. So this particular file, shatabdi.ts, we are bootstrapping all the content that we have written into this particular file so that the user can simply call it as and when whenever needed. So if I show you the live code, so using your framework becomes as simple as import Shatabdi from ./lib, that's the folder that we have, and then this file, and we simply call one function to load the entire framework. So as discussed, we are importing the router. We made the router and we are importing the router here. We made the responses module. We are importing the responses module here. And then we are importing the request and the responses interface. Now the .env library steps in. This library is very widely used to read values from the environment.env configuration files. This is completely optional. If you want to skip it, you can. And just in case you want to have custom ports, yes, you can do so. Now we create a class that is named as Shatabdi. You can name it anything as you want. Now these are just the data members that are storing the state of the framework at any point. Now let's move on to the constructor. The first thing which we do is we create an HTTP server instance and then store it in a method. This allows the server to persist the connection and it does not make the server rerun or restart on every incoming request. So we are persisting the created server as a data member. Now, this particular port, the every server would be listening to one port or the other. Here, what we are doing is we say that okay, this the port for this server would be process.env.port. This process.env.port is just reads a .env file on from the current directory, and it will assign the port. If you're not interested in doing this, you could do something like 3000. And what it would do is, if for some reason, if this is undefined, it would set the value as 3000. And this dot router equals to the new router. And when I say new router, this is the router that we had already made. We are just calling it here and assigning it here. Now, welcome to the part that the user finally uses. It is a public function, which means that the user can call it, and it is get. Now, get is, if you check out the usage, you say get, and you see the people using app.get, app.get, right? This functionality is provided from here. Now you will see the reason for defining a generic method that was the register method, and yet here the magic happens. You see, there's one function that's get. You can define a similar function like public post, right? And then the post will also have a pattern which would be a string. It would also accept different layers, and so we say okay, it would be an array of layers, and it would also not return anything. This would also be void. And internally, what this would do is they should simply app.router. Now, the only reason we are seeing these functions in your code editor is that we are using TypeScript. So we say we are going to register, and what would be the method? We say it would be methods dot, and because we have already defined an enumeration, we note that this can be one of the four methods that we have already described. So we say methods dot post, and the pattern. Pattern is the string, and then the different args that were passed to us. Now you see that how easy it is to extend support to any of the requests that any of the custom type of requests that you want to handle. If you want to handle more, you can do like get, post, put, delete, anything that you wish, right? So this was mainly the reason of defining one single endpoint to register the routes. Now moving on, we have the final function, that is the engine. What the engine does is it just says that okay, whatever request that comes in, we are going to store it, because again it would be used in every of the layers of the responses. We define a new response, this dot response. This basically is a global level which stores the responses that we are as and when different layers are editing the response. And we say that okay, whatever request that we have got is passed into the router dot process method. Now if you control click on it, router dot process method brings the control here, and it basically, as I've already explained, it processes and categorizes which request to attach to which layer. And then we finally export the function, and that is all. Now we move on to the final part, git checkout checkpoint 6. Now we are finally running it. We are running the framework that we have built. So in order to run the framework, we have to insert content into two of these files. I'll start with the file that we have no control over. That's the server.ts file. Now the server.ts file, what it does is it just includes the things that we have built till now. And then we mainly create an HTTP server. And whatever request that comes in, we assign an app.engine. Engine is a method that we already have described and I've already explained in the previous checkpoint. So we say app.engine. Whatever request that comes in, we typecast it into a method that we typecast it into an interface that we've developed ourselves, and then the response object that the HTTP create server returns, we also typecast it to an HTTP.server response type. And then we attach it to a port, and we are saying here port 3000, and it tells that okay, the port is listening on 3000. Now drum rolls for the final part, and this is app.ts. Now this is the framework that we have built. You simply see the framework being imported here, and then you see we are defining an application. We get app.get. Any request that comes in, and like the request can be of any type, the response can be of any type. Very hacky code in here. And then you write rest.json, and we want to run this. What do we say? Should we run the code? Let's try it out. We say npm run server. Hopefully it should work. Let's see what happens. Okay, it says listening on port 3000. So let's go to port 3000 and see what it returns. Yeah, it says error is false, and this is the root directory. Now, have we attached any route like that anywhere? Yes, I guess we have. It is here. We see app.get, app.get. If any request is being made on the root route, we see like any request or response objects that are passed, we are sending a response, and it is essentially just a JavaScript object. So if you want to customize it, just say hackathon, and we are saying SillyHacks. And then once you would see that because we are using NodeMon, as soon as we hit Control S, the server itself reloads. And yes, now let's refresh it. This hackathon is SillyHacks. Good, this group is working. Now in this one we demonstrate like are we actually like we know that we defined a method to write the headers. So is it actually working? Let's see if the responses that we are sending have these headers already attached or not. So what we have to do is we have to open /home. Extract all slash home. So let's see what all headers came along with. Okay, it says check headers. Now, if you look very carefully, this check headers was written using the second layer, and the responses are and the headers are set on the on the first layer. So this also demonstrates that our framework is capable of running code one after the other. It means the request is passing through each of the layers. Now this was essentially the first layer, and this was the second layer. The second layer, as you can see here, I'll see if we are getting the headers. So awesome. These are here. You see x dash author dash email. You see an email there. X dash author dash name. You see a name there. That is from where it is coming. And if you look down, you see x dash power dash by. It says SillyHacks 2020. Now the user is not assigning it anywhere. You wouldn't see SillyHacks header anywhere in this page. That is being done internally by the framework itself. So we are adding a signature to every response that's being sent. Now let's demonstrate if we are really able to handle multiple layers at once. So we say slash. I hope it doesn't. Yeah, no errors. Nice, nice, nice. Okay. The responses, the rest.status is being sent on the last layer, which says finished true, and we say that okay, we are getting the response which says finished true. Let's see if we've got the headers also. Oh, multiple, yeah. So look down to the image, look down to the screen, and you say all the middlewares that are there are being added to the response. Now these are being added to different through different layers, and this also proves the point that one layer does not overwrite the changes that are done by the previous layer, and that is the reason you have the set header middleware 5, and you see the middleware 5 also has signed it. 4 also is there, 3 also is there, 2 also is there, 1 also is there. So basically, this also is possible only because of the architecture in which we have modeled the framework. Because the request and the responses pass through from one layer and then they move on to the other layer. Now, the first layer added a middleware 1, 2. Then the request went on to the second layer. They added the middleware 3, 4, and then it moved to the final layer and they added the middleware 5, and it finally sent the response. This enables us to, if you want to extend this, you can just assign, you can just maybe write a plugin that, like as we have in Express, and you can just make it accept a request and a response, and then you can do anything in here because it is not blocking anything. So anything, it would just be like a layer in between. The request would come and the response would go. Now let's see what all do we have. Okay, this one's interesting. This is basically passing data from the URL itself. So that is part done. If you see params, the typical example, apple, banana, mango. You see on the one part, it says, okay, parents, let's see the URL first. It says parents. And then it's apple, mango, banana. They have described a wildcard here, which was :1, :2, :3. So, and whatever reg.params, we are just doing nothing. We are just converting it to a JSON response and sending it to the user. So if you see, you're getting something like this, and in the headers you would see content type is JSON, and you would see one :apple, that's parsed from here. Two is here, and it is parsed from here, mango, and similarly banana was parsed from 3. If you want to extend it, you can. And finally, it's also very important if you are maybe cutting dynamic applications and you want to read data from the URL. So this is like very core component that a framework should have. Moving on to the to custom responses thing. So if we check out app.get/responses. Now, there's nothing special about the response that we get in here, which says status is unauthorized. But what's pretty cool about this is I'll clear it and refresh it once. So you see that the status code as we have described res.status 401, you can see that the server is returning a custom status code as we had done here. So res.status 401.json, and we say, and that is the importance of returning the object from this particular function, and basically that makes possible method chaining. So you say res.status, and then or you can add any other method on top of it. So it is very important when you're assigning status, because it would be practically lame if you have a function which does something like this: this dot status 200, or say 500, and you cannot do anything beyond that, because many a times you would be required to send response to the user, and that is the reason you need something to add on top of this. That is the reason it must have access to things like you must be able to send, or you must be able to send a JSON response. So this shows off that we can send a custom response using our framework. Now, if you're concerned that did we actually handle the case of a 404, or what happens when a user enters anything out of the blues? So let's simply see. Okay, this is the 404 request. It says cannot get. Get is the request with which it's done, and this is the URL that user has entered. Now, let me show you one thing. You can also write any JavaScript that you want in here, because this is just a function. Every layer is just a function, just a normal JavaScript function. So if you want, you can do console.log. And if I show you, the server would just, yeah, the server is on back, and we have to open slash responses. Yes, and you see it says going live. Because essentially every JavaScript that exists, you can simply put it in here. Now, this is basically it, and you have a fully functional framework, and all that's done in just these files. And just in case you decide to dump off TypeScript, you can eliminate 1, 2, 3, and 4 files. So your framework would be just 1, 2, 3, and 4 files. So you can write a framework in as less as four files, and hardly 100 lines of code, I guess, in total. No, maybe a bit more, a 150 or something. That is all. That is all from my side, and I'm excited for your questions now. Yeah.
Hi, Yash. That was a really good session. It was very informative. Like the way you solve the errors could show that how people can mitigate those errors, and how even if they get those errors, how can they solve it. So let's see if people have any questions. Let me go through the comments, and let me see. I don't really find any questions on the comment section, but I have some questions from my side. So the very first thing is that what are the advantages having your own framework, like your own web framework?
Yeah. The first thing. Okay. Yeah, the first thing is the overhead that is there on any request, you significantly reduce it. Because if you go about the request if you ever console log a request from Express itself, you would see that there are a lot of properties that are added to every request, because they do a lot of processing onto every request. It basically slows the request down. Yeah, what
Okay.
I forgot to, yeah, thanks for mentioning this, because what I forgot to tell is I benchmarked this particular framework against Express, and I'll just share my screen. Just,
Sure.
yeah, is my screen visible?
Arpan, can you check that? Yeah, it is visible.
Yeah. So what I did was I wrote one particular API, and then wrote one part of it in Express, and the other similar exact copy of it using the framework that we ourselves have built, and then
Mhm.
wrapped it inside of a Docker container, and then ran a few tests on it. So if just in case if anyone's interested, there's a nest.js. You can look into the code and the method that you've used to compare, and I'll quickly show the results. This one is the framework that we ourselves have built. The minimum latency that we had was zero point 0.8 milliseconds, and for Express, the minimum latency was zero point 0.9 milliseconds. So the fastest
Okay.
request that they could process took zero point 0.9 and ours was zero point 0.8. If we take the largest request which they could process, for us we took 41.7 milliseconds, and for Express it took 46.7 milliseconds. So that's our framework was about 5
Okay.
milliseconds faster over there.
That's right.
And if you check the averages, if you check the median response rate for our framework was 1.2 millisecond, and for Express the same was 1.5 milliseconds. So yes, I can show the stats for it. The framework is a bit faster than Express, and that is one of the reasons why you can use it.
Okay, yeah, I see. All right. So like, so that is why it is more efficient to use your own framework like at time, right?
Yes.
Yeah. So is there any package that you have developed and people like from Celiac they can use that package or any package you would want to suggest?
Yes. Back in time, I guess I wrote a package which now in hackathons a lot of times you have to share content across people, and since
Right.
SillyHacks is a completely online hackathon, I guess this would be very much useful if you see it. It's a package which basically creates an index page for all the files that are there in the
Okay.
current directory, and you can quickly use any deployment method like surge sh or vercel, or even firebase, and you can just run that command in that particular folder. It would list all the files, assign links to them, and directly upload it, so you can
Um,
share it and the other person can directly access it.
that's really cool. Like, can you name it so that or like we can find it and we can share it on our Discord channel?
Yes, I'd be sharing just a second.
Yeah. So
It hasn't
if
been
you share the link.
It hasn't been published on NPM as of now. I'll be doing it today itself.
Okay, no worries. So like
Yep.
whenever you publish, just ping Arpan so that we can share it in our Discord group so that people might like it might be helpful for people if they want to use it, right?
Mhm.
So like I also had this question in my mind. So what is the favorite package? Like not just that you've built, but what is the favorite package you have come across?
That is a very difficult question. I'd say that's Jest by Facebook,
Okay.
and the reason for that is Jest is basically if you use it on big code bases to test it, you see
Mm-hmm.
how recursively it handles all the edge cases that exist, and how
Okay.
now it is not a problem that people would usually face when they are working with small base code bases. But once we move into a large code bases, running the
Uh-huh.
test for the entire project, whenever you submit a pull request, is very slow. It can take up to hours. So they have this but like
Right.
awesome feature which they run the tests which are basically dependent on the code that's being changed. So I
Okay.
really like this feature because it speeds up the testing like really fast.
Right, right.
So I'd say it would be Jest.
Yeah. So that's pretty amazing. And I don't have any questions from my side. Let me just check if there's any other questions. Yep, there's no questions in the comments too. So yes, it was so great to have you. If you like, I just wanted to ask you one thing. So if there's, what is that one thing you want to tell to people who are starting out with building their own frameworks or anything? Your
Yeah,
last sentence.
one thing that I'd like to say to the people who are usually in colleges, like stop going about following and taking courses and getting certifications done. Instead of that, instead of two courses you do, at least build one project that
Right, right.
you can say that I've built it from the starting to end. So that really adds value, and it also clears a lot of doubts that you have.
Oh yeah, yeah. So I completely agree because sometimes when you do course and you're not able to show your knowledge. Like if you do a project, you are able to showcase that, right? I completely agree. Yeah.
Yeah.
So like, thank you for joining us. Okay, so people, if you want to register to Silly Hacks and if you want to be notified, so make sure you subscribe to Culture Studio. And if you like if you like this session and if you want more sessions, like just click on the notification button so that you're notified about similar sessions. And yeah, that's it. That's it from our side. Thank you for joining in.
Thank you, everyone.